Good morning, students. I hope you're all fine with good health. Please take care of your health. Prepare your lessons from home. The last few video sessions, we have been covering your Unit 2, the chapters which are covered in Unit 2. One is Python variables and operators. Second chapter is control structures. Now we'll be moving on to the third chapter, Python functions. You might have come across functions in Dev C++. Of course, you are a little bit familiar about this topic. So you can easily understand this topic when I teach you. So listen carefully. What's the reason they are using functions in program? Of course, point number one, functions help to divide program into smaller tasks. Whenever your program is very big, we have to divide that program into smaller tasks. The second point also states that very clearly. As our program grows larger and larger, function makes it more organized and manageable. Third point, it avoids repetition and makes code reusable. The same coding cannot be repeated again and again if you use functions. Code developed can be reused in many places of a program. Modularity. What do you mean by modularity? The word meaning for this modularity is splitting a program into many modules. Of course, you know, functions are called as building blocks of a program. Programs are especially built with blocks. Last point, bugging and debugging becomes easier in function. Bugging, you know, it's an error. Debugging, removing error. This two process becomes easier when you use functions, right? So these are some reasons why we use functions in program. Now let us go inside our chapter. And one more thing I have to show to you. When you look at this diagram, in a program, we can have one or more functions. These functions can be saved as module, and the module can be saved in your library files. So whenever you require this module, you can use it. Through this module, you can call these functions. So only they state like this. A group of lines with some name is called function. A group of functions saved to a file is called module. Right? Okay. Now the topics what we are going to see today is definition of function, advantages of function, types of function, syntax of user-defined function, advantage of user-defined function, calling function and passing parameters, function arguments, anonymous function, return statement. First, we will see what is the definition of a function. We can define function by these two ways. Number one, functions are named blocks of code that are designed to do specific job. Second form of defining a function, group of related statements that perform a specific task. You all know how the blocks are created in Dev C++. There we have open curly brace and closing curly brace to indicate the beginning of the block and end of the block. Whereas in Python, we do not use open curly brace and closing curly brace, but we use indentation. Spacing is called blocks in Python functions. Okay. Advantage, it avoids repetition and makes high degree of code reusing. A function developed in one program can be reused in n number of programs. Second advantage, it provides better modularity of your application. I explained you what is modularity. Splitting programs into many modules is called modularity. These are the two advantages of using function. Then types of function, what you are going to learn in Python is totally 4. Number 1, user-defined function. Number 2, built-in function. Number 3, lambda function. Number 4, recursion function. What is user-defined function? Functions defined by the user themselves. We call that as user-defined function. If a programmer is going to define function of his own, we can call that function as user-defined function. Second one is called built-in function. Functions that are already built up in Python, we can call that as built-in functions. We have some mathematical built-in functions in Python. We'll be learning in the same chapter. For example, sum, square root, etc., etc. That we called as built-in functions. Functions which are already built up and kept in your Python library, we can call as built-in functions. Lambda function. This is a new topic you're learning in Python. Functions without name. Normally, functions will be defined with name. Here, we are going to define a function without name. A function without name is called lambda functions. They are also called as anonymous functions. So only they call unnamed functions. Recursion function. Function that calls itself is known as recursive. Normally, we have to call function by its name. Sometimes a function can call itself. That type of functions are called as recursive functions. Now we'll learn how to declare a user-defined function. This is a syntax for declaring user-defined function. Every user-defined function begins with a keyword name called DEF. DEF, it stands for definition, followed by function name. Within parenthesis, we have your parameters. The first line of your function should be ended by colon, then followed by block of statements which you are going to define under a function name. Every user-defined function will end with return statement. Now, a small example is being typed at the bottom here. Have a look over. I said you every user-defined function begins with what keyword? Definition, DEF, followed by function name, followed by parenthesis. Here the parenthesis is empty, no parameter has been passed. And you have to end that first line of your definition by giving colon. When you press enter, we can see a space is being generated. This is called indentation. In Python, blocks of a function is created by indentation. In print statement, we used a string called hello Python. String should be enclosed within double quotes. Close your parenthesis. Right? Every user-defined function will end with return. So I think you can understand the syntax and the small programming code given at the bottom of your syntax. So they are defined here. Function blocks begin with a keyword def, followed by function name and parenthesis. Any input parameters or arguments should be placed within parenthesis when you define a function. The code block always comes after a colon. The statement return exits a function, optionally passing back an expression to the caller. A return with no argument is the same as return none. So that explanation of the syntax is given here. Right? Block. Still, you have an idea about block, what you have learned in Dev C++. There we will be using open curly brace and closing curly brace to define a block of a function. In Python, we are not going to use open curly brace and closing curly brace, but indentation is going to create that blocks. So they define a block in Python like this. A block is one or more lines of code grouped together, treated as one big sequence of statements while execution. In Python, statements in a block are written with indentation, with space. What is nested block? A block within a block is called nested block. Now, advantages of user-defined function. You have learned advantages of function in the previous topic. Now you are going to learn advantages of user-defined function. First point, functions help us to divide a program into modules. So we can divide a program using functions. Once you divide that program into functions, that functions are called as modules. It implements code reuse. A module created in one program can be reused in another program. Functions allows us to change functionality easily, and different programmers can work on different functions. These are the advantages of function. Now I'm going to share your PyCharm window to explain about functions. So listen carefully. Right. Here, I have already typed a program here. I said your user-defined function begins with what keyword def, it stands for definition, space, followed by function name. Here the function name is hello, followed by parenthesis. Inside parenthesis, you'll be giving parameters. Of course, here parentheses are empty. Nothing has been passed. Then you end this line of defining the function by giving colon. Once you give colon and press enter, we can see some space left over here. This space indicates that indentation of the function begins. That is called block. Now, what's the first statement here? I'm using my print. In my print, within my brackets, I'm using a string hello Python. Then I said you every user-defined function ends with return statement. So function is being defined and its block is being defined. Now I'm going to call this function. How will you call? Functions can be called by its name. So print within bracket, I'm using hello. What is hello here? Name of the user-defined function. So I'm calling this function with its name. When I'm calling, I do not pass any arguments. Your function will be called. When the function is called, the block inside this function will be executed. What does the block contain? A print statement indicating to print hello Python on the screen. Once it prints hello Python, the next statement is return. Normally, return, we should use any expression list. Here, we have an empty return statement. According to Python, if you are going to use empty return statement, it returns none. What does the none indicate here? Return statement does not pass any value to the function caller. That is, hello is called the function caller. It does not return any value to the function caller. Right? Okay. Let us create a new file. I am typing here as module.py. Right? I'm going to create a module. I'm going to show you how to create module and how to use this modules in program. So observe carefully what I'm saying. Right? Now you have learned how to define a function, isn't it? And how to create a function. Now I'm going to use that process here. So I'm defining a function called add. Def, of course, is a keyword. You know, it stands for definition, space, followed by function name. Within bracket, I type here A, comma, B. So these two are called as your parameter values. Colon, enter. Print, open your bracket within double quotes. The sum of two numbers, A and B. A and B. Close your double quotes, put comma, then type A plus B. Okay, I have defined one function here. I am going to define one more function. Let that function name can be sub. It stands for subtraction. Okay, same parameters I'm using here, no problem, because the different function here, A comma B, put a colon, right? Then type print the difference between two numbers, comma, A minus B. So there are totally two user-defined functions defined in this program, and I am saving that program as module.py. Are you clear? Are you clear? Right. Now I'm going to open a new file here, and I'm going to name that file as some name here. I'm using fun31.py. Right. Now I'm going to import that module. Without importing, we cannot use that functions what you have used in your module.py. So import module, module. Okay, a module has been imported, right? Then module dot. Once I place a dot, okay, we can see the module what I have saved contains two functions, add and sub. Now use your add user-defined function and pass two values, 10, 20. Are you clear what I'm saying? Right. Then module dot, I think the next user-defined function is sub, sub. Within bracket, I give 50, 40. Okay, wow. Now I am going to run this program, fun31.py, and importing two functions from module. I said you functions can be saved as a module and that code can be reused in some other program. That is called modularity. Dividing or splitting a program into many modules we call as modularity. Function supports your modularity. Compile this program. Of course, you can see the result here. The sum of two numbers A and B is 30. The difference between two numbers is 10. In module, I have defined this procedure and I've used that procedure in another program. This is called code reusing. Are you clear? Right. We'll move on to next topic. I explained you about this program. Then passing parameters in function. See, normally within this parenthesis, we use parameters. We define the parameters of a function. The parameters that placed in the parenthesis will be used by the function itself. Can pass all sorts of data to a functions. Here we have a small example. Here the function name is area. W and H are called as parameters. For these two parameters, I pass the value 3 and 5. So from the function caller, you'll come to your function definition. W will receive the value 3. H will receive the value 5. I'm calling this user-defined function area by its name. Under your print statement, when I'm calling, it is going to print the value 15 on the screen. So arguments are passed from function caller, and that argument values are received by the parameters of defined function. This is the process that takes place in your parameter passing. We can pass arguments in function by 4 ways. One is called required argument, one is called keyword argument, one is called default argument, and one is called variable length argument. We are going to see all these things one by one. First one is required argument. This required argument can be otherwise called as positional arguments. Arguments passed to function in correct positional order. The number of arguments in the function call should match exactly with the function definition. At least one parameter is needed to prevent syntax error. Now look at an example here. The name of the user-defined function is print strings. Print string. I am calling this function print string. I am passing the argument welcome. This argument welcome will be substituted to the parameter str. What is defined in your user-defined function. So this welcome string will be passed to a parameter str. This welcome argument will be passed to a parameter str. Str will receive that argument, print that argument on the screen. What argument has been received? Welcome. Are you clear? Then keyword arguments. Here, when you are passing argument, the arguments are being named, that we call as keyword arguments. Keyword arguments will invoke function after the parameters are recognized by the parameter names. See, normally within parenthesis of your user-defined function, we use parameters. We have a name for the parameters. Here, I am passing an argument. This argument is being named with name. So, when you pass argument with a name, it goes to your parameters, and your parameter is able to recognize that keywords by its name. So, what's the name of the argument what I pass in this program? The name of the keyword argument what I pass here is name, and that has been recognized by the parameter in the user-defined function. So the value of the keyword argument is matched with the parameter name, and so one can also put arguments in improper order. This is proper order. Now it's an example to show you what is improper. Now I am using this function print data, one of the user-defined function. I'm calling this function print data. I'm passing two values, 25 and Ravi. But the parameters what I've used in my user-defined function is name and age. But when I'm passing is age and name. So in keyword arguments, the arguments can be not in proper in order. But how does the parameter is going to recognize that? Every argument what you pass contains a name. With the help of the name, the parameter is going to recognize. For example, if I'm passing Ravi, Ravi is an argument. This argument is being named by name. So this is a name for the keyword argument. That name will match with the parameter. Now I pass 25 for age. Age is the name given for the keyword argument, and this name will match with the parameter. Now the keyword arguments are not proper in order, it is improper in order. This we can do in your keyword arguments. Default arguments. Now, what is a default argument? Argument that takes a default value. If no value is provided in the function call, we can call that as default arguments. Here, I'm using the same function print info. And there are two parameters here. First parameter name is name. Second parameter name is salary. For salary parameter, the value has been assumed. So salary becomes the default argument here. Now I pass this argument money. This argument will be received by the parameter name. But I do not pass salary because salary is already defined. This is called the default argument. Default argument will take the default value what is defined in your user-defined function. Variable length argument. This is a new concept. Variable length arguments are not specified in function definition, and asterisk is used to define such arguments. Now look out this example here. Here the name of the user-defined function is sum. How many parameters it contain? 3. But when I'm calling this function sum, I'm passing 5 arguments. How many parameters are there? 3. But I'm passing how many arguments here? 5. So mismatch. So you will get an error because the number of arguments what you pass does not match to the parameter list. So at that time, what we can do is, sometimes the number of parameters what you pass may vary. At that time, you can use the sign asterisk to get variable length argument. You can pass n number of arguments. According to it, it will receive the value just by indicating star. That is called asterisk. That asterisk sign will just know how many arguments are passed as a value to these parameters. Now we can see an example for variable length argument. Now my user-defined function name is print numbers. Right? I'm going to call this print numbers 2 times. When I'm calling print number for the first time, I pass 2 values, 1 and 2. When I call this print number for the second time, I pass 3 values. So the number of arguments first time is only 2. Number of arguments in the second time is 3. So the argument value keeps on changing. So when the argument value keeps on changing, you can use the concept variable length argument. So when I pass 1, 2, 2 arguments are passed and that will be received by NOS. The star will indicate how many arguments has been received when you pass the value. Second time I call this print number, I'm passing 3 values. Now the star is able to recognize how many arguments are passed. 3 arguments are passed. So first time I pass 2 arguments. Second time I pass 3 arguments. So the length of the arguments keeps on changing every time. At that time of process, to manage the number of arguments what you pass, we can use asterisk in front of your parameter value, or we can call argument value. Anonymous function. A function that is defined without a name. Normally we define a function with name. Here we are going to define a function without name. So function without name are called as anonymous function. Here anonymous functions can be defined by using keyword lambda. Anonymous functions are also called as lambda functions. Lambda function is mostly used for creating small and one-time anonymous function. Now we are going to see the syntax of anonymous function. Lambda, arguments, colon, expression. Look at this example here. Sum equal to lambda, argument 1, argument 2, colon, expression, argument 1 plus argument 2. See, there is no function name here, but I am able to receive 2 arguments. Sum is the name of the variable which is going to pass these 2 values, and that will be received by your lambda, and that arguments will be summed up and kept in your variable sum. Right? First time I pass 30 and 40. These 2 arguments are received by the lambda function, and this expression is evaluated, and the value has been saved in the variable sum. Second time I pass minus 30 and 40. Lambda arguments are going to receive the 30 and 40, evaluate that expression, and store the result 10 in the sum. First time I store 70, second time I store 10. Return statement. Of course, every user-defined function ends with what statement? Return. That is called exit of a function. We can use n number of return statements in a program, but only one return statement will be executed. If a return statement contains no expression, by default, return statement will return none as a value. Right? Here an example to find out a positive number and a negative number. The name of the function is USR underscore ABS. And I'm passing an argument X. The value of X is being substituted to parameter N. If the parameter value is greater than or equal to 0, I return N. Else, I return N. See, here both the things are totally different. If I enter a positive value, I'll get a positive value. If I enter a negative value, the condition is checked. Minus 25 is greater than or equal to 0, condition is false. So return N means it is going to return minus 25. So positive means true block will work. Negative means false block will work. So we have used two return statement, but only one return statement will be executed. This is the assignment for this video session. Finish this assignment and keep it ready. Please finish these assignments in your classworks. When the school reopens up, you might have to submit your classworks without fail. Let me show you some more examples on your PyCharm to make your understanding clearer. Right? An example what I said you about keyword argument. Keyword argument can be improper in order. Execute and see this program. Even though we are able to pass in improper order, parameter is able to receive that. How? Because every argument has been named up. So this name of this keyword argument is going to match with the parameter name. Are you clear? Then a program for default argument. A value is being assumed to your parameter that becomes a default argument. Here there are two parameters, name and salary, but I pass only value for the first parameter, but I do not pass the value for the second parameter. But without passing the second value, it is able to adjust because salary is called the default argument and the value is being specified to it. Example for your default argument. Right? Then example for your lambda, we call as anonymous function. Right? Function without name. So lambda is used for creating anonymous function. So when I pass 30 and 40, it will be received by the lambda argument. That value will be summed up and kept in your sum. Second time I pass minus 30 and 40, the argument of the lambda function is going to receive that and it's going to keep in sum. So the value of the first time will be 70, second will be 10. Execute this. So sum is 70, sum is 10. Then, okay, a program to print positive and negative number. Execute this program. Now I give 25. So it prints 25 on the screen. It's a positive number. So it returns a positive number to the program. The same program has been executed with a negative number. So it returns a negative number. What's the idea behind this program? Even though we use multiple return statements in your function, only one return statement will be executed. Right? That's all for today's video session. We'll meet in the next video session. Thank you.